Hidden Greenland Lake burst through ice in shocking 2014 event, scientists explain. A remarkable event unfolded beneath Greenland's ice sheet, leaving scientists in awe. In 2014, a subglacial flood, a phenomenon rarely witnessed, occurred near the Harder Glacier in northern Greenland. This flood, an upward surge of water, punched through tens of meters of ice, creating an incredible spectacle. Imagine a deluge so powerful that it pushed up blocks of ice, each the size of a 5-story building, and scoured an area nearly twice the size of New York's Central Park. Winnie Chu, an assistant professor of geophysics, described it as extremely surprising. The conditions required for meltwater to force its way up from the bed are indeed unique and extraordinary. It was a decade later, in 2025, that Mal Macmillan and his team at Lancaster University discovered this event while analyzing satellite imagery for signs of subglacial lakes. These lakes, formed from meltwater on the surface, play a crucial role in Greenland's water cycle and ice movement. Typically, they drain and get trapped between the ice and bedrock, but occasionally they rapidly empty, causing a chain of events that can accelerate glacier flow. The team's discovery near Harder Glacier revealed a collapsed area, an 85-meter deep sinkhole, indicating a rapidly drained subglacial lake. Beyond this fracture zone, they found 6 square kilometers of smooth ice, evidence of a massive deluge. The water, unable to flow downstream, pushed upwards, creating an upheaval of ice and a dramatic release of 90 million cubic meters of water within just 10 days. But here's where it gets intriguing. The water, after its dramatic surge, drained back under the ice sheet, possibly ending up beneath Harder Glacier. Coincidentally or not, the glacier experienced a significant calving event during the same period, with a chunk of ice plunging into the sea. The glacier's flow rate also exhibited unusual changes that summer, suggesting a direct impact from the flood. Robin Bell, a professor at Columbia University's Lamont Doherty Earth Observatory, emphasized the importance of this event, stating, "This is another piece in the puzzle of how big pieces of ice on our planet work." Macmillan added, "We need to understand whether this has happened on other occasions." This event highlights the complex dynamics of Greenland's ice sheet and its rapid warming, leaving us with more questions and a deeper appreciation for the power of nature. So, what do you think? Is this event a rare occurrence or a sign of a larger pattern? Feel free to share your thoughts and interpretations in the comments below. Uncovering Greenland's hidden flood, a glacial mystery solved. Imagine a hidden deluge so powerful it could carve a crater through hundreds of feet of ice in just days. That's exactly what happened in Greenland in 2014, when 90 billion liters of meltwater, roughly equivalent to 9 hours of Niagara Falls peak flow, erupted through the ice sheet in a previously undocumented event. Scientists call it a game changer for understanding how ice sheets behave under climate stress. But here's where it gets controversial. This discovery challenges long-held assumptions about how meltwater moves through ice and into the ocean, raising urgent questions about the accuracy of current climate models. And this is the part most people miss. The flood didn't just melt the ice, it fractured it, leaving behind a 2.5-kilometer wide crater and ice blocks towering 25 meters high. How did this happen? Let's break it down. The event unfolded when a subglacial lake, a body of liquid water trapped beneath the ice, suddenly drained. Researchers, led by glaciologist Jade Bowling from Lancaster University, stumbled upon the anomaly while analyzing satellite data. At first, they suspected a glitch. "We thought there was an issue with our data," Bowling explained, but as we dug deeper, the evidence pointed to a massive flood escaping from under the ice. This was the first time such a phenomenon had been observed in Greenland, a region home to one of Earth's 2 permanent ice sheets, the other being Antarctica, covering 1.7 million square kilometers, nearly 3 times the size of Texas. Greenland's ice sheet is already losing 30 million metric tons of ice every hour. Now this study reveals another, less understood player in the melting story: subglacial lakes. These hidden reservoirs, only recently discovered beneath the ice, are fed by surface meltwater. But their role in the broader hydrological system remains a mystery. The 2014 flood, detected using data from NASA and European Space Agency satellites, showed just how dramatic their impact can be. Over 10 days, the meltwater surged upward, blasting a 279-foot deep crater into the ice and scouring an area twice the size of New York's Central Park. Further downstream, the flood fractured the ice into massive, uprooted blocks. This contradicts earlier models that assumed the ice sheet's base was frozen solid, not a dynamic system capable of sudden, catastrophic drainage. The implications are staggering. If subglacial lakes can contribute such vast amounts of water to the ocean through drainage events, they could accelerate sea level rise far more than previously estimated. Co-author Amber Leeson, also of Lancaster University, emphasized the study's surprises. It has taught us new and unexpected things about how ice sheets respond to extreme meltwater inputs. We need to rethink how we model these systems. So, what's the takeaway? This discovery isn't just a scientific curiosity, it's a wake-up call. As global temperatures rise, could more of these hidden lakes burst, amplifying ice loss in ways we haven't accounted for? Are our climate models underestimating the speed and scale of Greenland's melt? Let's discuss. Do you think this study changes how we should approach climate predictions? Share your thoughts below. Colossal flood in Greenland. Ice sheet's hidden lake explosion. A massive flood unleashes from the Greenland ice sheet. Scientists stunned by the aftermath. In 2014, an astonishing event unfolded beneath the Greenland ice sheet, when a concealed lake began to drain unexpectedly. This dramatic occurrence unleashed a powerful surge of water that shot upwards, cleaving through the ice and forming a crater nearly 1 kilometer deep. Over the subsequent 10 days, an astounding 90 million cubic meters of water gushed from the lake, an amount comparable to the volume of water that would cascade over Niagara Falls in just 9 hours during peak flow. This incident stands as one of the most significant subglacial floods ever documented in Greenland. However, the true surprise lay not just in the flood itself, but in the shocking discoveries made downstream. Researchers found a staggering 385,000 square meters of ice, equivalent to 54 football fields, fractured and distorted in a chaotic landscape. This area featured massive ice blocks towering 25 meters high, alongside 6 square kilometers of ice that had been scoured clean. Remarkably, none of these features existed prior to the flood. In a recent study published in the journal Nature Geoscience, scientists from Lancaster University have shed light on this extraordinary flood and its implications for understanding how the ice sheet might react to future climate changes. The flood's revelation. The study highlights that one of the most recently identified yet poorly understood aspects of Greenland's subglacial hydrological system is its network of active subglacial lakes. The 2014 drainage event provided a unique opportunity to delve deeper into this phenomenon. Utilizing high-resolution surface models and data from multiple satellites operated by NASA and the European Space Agency, the research team meticulously analyzed the lake and the flood event. Their findings were unexpected. Lead author Dr. Jade Bowling remarked, "Initially, we thought there was a problem with our data because the results were so surprising. However, as we conducted further analysis, it became evident that we were witnessing the aftermath of a massive flood of water escaping from beneath the ice. Traditionally, it was believed that meltwater flowed from the surface down to the bedrock and eventually into the ocean. This event, however, demonstrated that water could also be propelled in the opposite direction, forcing its way upward through the ice due to pressure. Approximately 1 kilometer downstream from the collapsed basin, a new fracture zone emerged on the ice surface, characterized by crevasses and uprooted ice blocks that reached a combined height of 40 meters. The study noted that a region of about 6 square kilometers of the ice surface had been thoroughly scoured. These observations suggest that a significant volume of water surged upward through the ice at this location, flooding the surface. The researchers were also taken aback to discover that the flood occurred in an area where previous models had predicted the ice was frozen at the base. Given the presence of the lake, this assumption was clearly incorrect. Scientists propose that the pressure-induced fracturing of the ice at the base may have created a pathway for the water to escape. Insights gained from the flood. Dr. Amber Leeson, an expert in ice sheet hydrology, expressed her astonishment at the findings, stating, "This study has revealed many unexpected insights into how ice sheets can respond to extreme inputs of surface meltwater. These revelations prompt critical questions about whether existing models accurately reflect the behavior of the Greenland ice sheet in a warming climate." Researchers caution that as global temperatures continue to rise, we may witness more meltwater events like this one. Yet, there remains much to learn about their impact on the future of our ice sheets. For further details on this groundbreaking study, you can read the full article, "Outburst of a Subglacial Flood from the Surface of the Greenland Ice Sheet." Final thoughts. This remarkable event not only highlights the dynamic nature of Greenland's ice, but also raises important questions about our understanding of climate change. How well do you think current models predict the future of ice sheets? Are we prepared for the potential consequences of such dramatic changes? Share your thoughts in the comments.